Hello everyone, this video is going to contain everything you need to know to get started on Project 2 maps. We recommend following the same workflow as introduced in this video. So after you get your project, let's dive right into the structure. So once you open up your project in IntelliJ, the structure should look something like this. If you look at Maps, Source, and then Maps again, you'll see that this file here, array map and chained hash map, are contained in this folder, and these are the only files that you'll need to change for this project. So each of these files have two classes. They have the map class, and then they have an iterator class. So there are 4 classes total that you're going to be implementing. So now we know where to make the changes. The next step after that is to look at the interface and the methods that we're going to be implementing. So the specification, I'm moving on to the map interface page, tells us some descriptions for the methods that we need to write, which is helpful, but sometimes you want more detailed documentation. So if we go back to IntelliJ, we can see that both chained hash map and array map extend abstract iterable map up here. I recommend looking for the abstract iterable map file, which contains more documentation for those methods. Now, whenever you want more information on a method or a class or an interface, you could search for the file manually in the file tree on the left panel, but sometimes you want to see documentation that you don't have easy access to, or you don't know where that file is. There are a few shortcuts to immediately jump to the documentation that you want. One way to do this is, if you're on Windows like me, hold Control, and you can see that by hovering over these, I'm being taken to where these things are being declared. If you're on Mac, you can hold Command and do the same thing. Alternatively, you can right-click over the term, so hover over Go To, and then see Declaration or Usages. We're going to click on that. Now we're being taken to where that word was defined. So right now, I clicked on abstract iterable map, and now I'm being taken to where that class was defined. So according to the specification on the website, we're required to implement these 7 methods in addition to some extra constructors. I recommend looking at the more detailed documentation that I just introduced you to. For example, you can see that get, for example, has a lot more stuff going on, and it might be more helpful to read through that while you are implementing it. Just to run through these, you can see that there's put, there's more docs for remove, clear, contains key, size, and of course the iterator method. As a quick tip and a reminder, the size method should return the number of key value pairs in the map. So it's not the size of your underlying array, it's the number of key value mappings. I also want to add 2 important notes. I'm going to go back to the spec. In lecture and in section, we often visualize key value pairs as taking up 1 index of an array. A common question that we get is, if an index of an array can only hold 1 thing, how can we store both a key and a value in that 1 index? To answer that question, we go back to the starter code for the array map. You can see that we give you a field that is an array of simple entries. So let's take a look at what the simple entry is. Using the trick that I showed you earlier, we go to simple entry. You can read the documentation here if you want. This is an object that holds both a key and a value as private fields, and you can access them using various methods. If you look down here, you can get the key, get the value. You can also change the value if you would like. So you can work with this object as you're working on your both array map and your chained hash map. The second important point that I want to make is also listed on the spec, but is often missed. There may come a time when you want to check for object equality, but you're not sure if one object is null. So for example, if you're comparing keys, you might not know if one key is null or not. In that case, you're going to want to use objects.equals, this method here in this exact format. So you might have to import java.util.objects. This equals method here is different from, for example, a.equals b. It's also different from a== b because it accounts for the null checks that we need for this project. Keep in mind that this is objects with an S. Keep in mind that if you're running into null pointer exceptions throughout your project, checking the equality of two objects might be something to look for. So that's all about the map interface. Let's move on to the implementation details for the array map. In addition to the required methods in the map interface, you should also have two constructors, the array map and the array map with this parameter of the initial capacity. You can see that the project specification has really good examples of how your internal array should look. As a hint and as a reminder for how to exactly implement the methods, the underlying array should never have holes. So instead of having an array that looks like this, you should always have an array that is filled in. So all of the indices up to that point are filled in. Just to go over the other requirements, let's go down here. All methods must run in big O of n, where n is the size of the map. The size and iterator methods must run in constant time. And you don't have to downsize your array, but you do have to increase the size of your array once it's full. After you implement the required methods for the array map, the next step is to implement the array map iterator. So you can see some of the method descriptions here. You're only required to implement hasNext and next in addition to a constructor. There's a recap of how an iterator works on the course website. If you're looking for more documentation on the iterator, as I said earlier, you can scroll down to the iterator class. You can see that it implements iterator. Right-click, hover over Go To, and then go to Declaration or Usages. And you can see a lot more detailed documentation on the hasNext and next methods here. Just a reminder that ArrayMap Iterator is a class in your ArrayMap. So it is not a new file, it's still in your ArrayMap file. Just to go over the requirements, you may not create new data structures, and both next and hasNext must run in constant time. You can assume that no client will modify an ArrayMap while an iterator is in use. Some common issues that we have in office hours, don't use the ArrayMap iterator when you are implementing the ArrayMap. So implement the ArrayMap first and then do the iterator. The reason for this is because the iterator is meant for clients of your ArrayMap, right? They want to go through your ArrayMap. Similarly to how you, as a client for a list implementation, you can use an iterator for that list. To make things easier, you can reuse the hasNext method in the next method to save time, since some of the checking requires similar logic. Okay, this is quite a long specification. That's all for the array map portion of the project. I recommend pausing right now. Come back to the video once you've finished implementing array map and the array map iterator. And also, don't forget to take breaks. Welcome back. Let's move on to implementing the chained hash map. In addition to the same methods that you implemented for the array map, you'll want to implement the constructor. So there's going to be two constructors. One has no parameters and one has 3. You will have to define these values as an explanation for what they are. You can see that count is the number of buckets or the number of chains. And then the initial chain capacity is the initial number of possible entries per bucket or per chain. And then there's another parameter called the load factor threshold. That's the ratio of the number of key value pairs in the data structure compared to the number of buckets. And this ratio dictates when you resize your separate chaining hash table. We recommend doubling the number of buckets when you're resizing. Also, when you're resizing, don't forget to rehash. So for all of the existing entries, make sure to rerun the keys through the hash function and then mod by the new table size so that they go into the correct index. Let's take a look at a couple of the hints. If your chained hash map receives a null key, make sure to use 0 as a hash code. Now we are using separate chaining, but unlike lecture where we use a linked list, this project is going to ask you to make each chain into an array map, the thing that you just implemented instead. So instead of calling the array map constructor, however, we do give you a provided method. It's called the create chain in order to instantiate your array maps. And this is in your chained hash map starter code. If we scroll up, we can see some examples of how our data structure should change as we call these different operations. And if we go back down, please do not try to implement your own hash function. We have Java's object.hashcode. I have an example listed here of how to use that. So if you have a key A, in order to get the hash code for that, you should do a.hashcode. And don't forget to mod by the table size. And you can assume that the hash codes returned by this method have a pretty even distribution. Let's take a look at the other requirements. All methods should run in constant time except when resizing. And then when you're resizing, put may run in big theta of n time, where n is the size of the map. It should be the map. And similarly to array map, you don't have to downsize your data structure if a lot of elements are removed. Let's move on to the iterator for the chained hash map. This part, a lot of us argue, is the trickiest part of the project. Just like the array map iterator, the project asks you to implement the hasNext and the next methods. Now there are a few ways to implement this iterator. We highly recommend that you consider invariants that might be useful and comment them somewhere in your class as a reminder to yourself and your group mates and to any TAs who are trying to help later on in the project. Invariants reduce edge cases that you'll need to handle. You can see the bullet list up here for some examples of some invariants that you might want to use. And of course, feel free to come to office hours if you're having trouble coming up with good invariants. A couple of other tips for this iterator: you can use as many fields as you want and try to reduce redundancy. If your code requires the same operation more than once, I recommend writing a helper function for that operation. Logic in advancing to the next chain, for example, can be reused in both hasNext and next. And yes, you can call hasNext in the next method as well. If you get stuck, you can try designing an algorithm using pencil and paper. And to just go over some common issues, it's best to not directly access fields of your array map. So it's good to think of yourself as a client to the array map instead. Try to iterate through the array map just as any client would. For example, you hint should use the iterator that you just implemented for the array. Once you implement the chained hash map iterator, you're all ready to submit. So make sure to submit on Gradescope. Remember, if Gradescope doesn't have it, then it's not submitted. And also Gradescope does have hidden tests. For more information on how to replicate those tests, you can stay tuned for a video that's coming soon. Thank you all for watching and good luck on the project.